This is the second way to solve example 3. So if you've already watched the first way where I eliminated the x's, you can skip to 2 minutes and 15 seconds. This is example 3 for the 8.4 lesson. So we're going to solve the system using elimination, just as we have been doing. So we want to look at our system and realize that adding the equations together right now won't do anything. 3x plus 5x is 8x, 4y plus negative 7y is negative 3y, so nothing eliminates. So we want to multiply one or both of the equations by something so that the coefficients match except one's positive and one's negative. So let's see if we can easily eliminate the x's. So what can I multiply 3 by to make it 5? Well, there is a number that will do that. It's 5/3, but we don't want to mess with fractions, so that's not easy. Same thing, to multiply something by 5 to get the 3 would be 3/5. Again, we don't want to deal with fractions. So the x's don't look easy to eliminate. So let's look at the y's. What can I multiply 4 by to get 7? It's another fraction. Well, what can I multiply 7 by to get 4? Another fraction. So what that means is there's no way to solve this system by multiplying just one of the equations by something. We're going to have to multiply both of the equations by something in order to get those coefficients to match. The reason why it's been pretty easy so far is if you look up like in the previous example 2, we could easily get 2 to become 6 by multiplying by 3. So since 2 was a factor of 6, or you could look at it as 6 is a multiple of 2, we could easily get these to match by multiplying just one of the equations by something. That's not the case down here. 5 is not a factor of 3, or 3 is not a factor of 5. 4 is not a factor of 7, and 7 is not a multiple of 4. So we don't have it that easy for this one. But luckily, it's not too bad. We just have to multiply both equations by something so that the numbers match. So I'm going to show you how to do it two different ways. This is the second way to do it. So if you want to learn the other way to do it, you can watch the first video. And it really doesn't matter which one's the first or the second way to do it. It's just that they're different ways. So if we're going to choose to eliminate the y's here, we need to multiply both of the equations by something so that these two coefficients match, but one's negative and one's positive. But if you look, one of them's already negative. So if we multiply by a positive number, the coefficient of the y term is already negative here. It's already positive here. So we still have to make sure that in the end, whatever two equations we end up with, one's a positive number and one's the same number but negative. So we need to find a number that is a multiple of both 4 and 7, or a number that 4 and 7 both divide evenly into. And we want it to be the smallest possible because it's just easier that way and it's smaller numbers to deal with. So what number do 4 and 7 both divide evenly into? You should know that that's 28. So we want to get both of these numbers to be 28, except one of them to be a negative 28 and one to be a positive 28. Again, since this number is already negative, let's make this one a negative 28y and this one a positive 28y. So to do that, we're going to have to take each equation and multiply it by something. So I'm going to take equation 1 up here. So I'm going to put parentheses on both sides, so that's equation 1. And I'm going to multiply by 7 because that's what we multiply 4 by to get 28. So I'm going to multiply both sides and every term by 7. So when I say every term, remember that means we are distributing. So 7 times 3x is 21x. So I'm just going to copy down the new equation down here. Then distributing the 7 to the 4y, 7 times 4y is positive 28y. Equals, on the right side, we still have to multiply 7 by that number over there. And let's see, 112 times 7 is 784. So that's our new equation 1. So although they look different, they represent the same relationship. If we were to graph both of them, it's the same exact line. So it's just scaled up because we multiplied it by a constant term. Okay, so now that we did that, and remember we had to multiply, what we did to one side, we had to do to the other side. So now let's look at equation number 2. What would we multiply equation number 2 by so that the coefficient of y is a negative 28? It's already negative 7. So we're going to multiply it by a positive 4 because positive 4 times negative 7 gives us negative 28. So again, put both sides in parentheses because we have to remember to multiply each side and every term by that same number. What you do to one side, you have to do to the other. So let's distribute here. So we have to multiply 4 by 5x, gives us 20x. And again, I'm just writing it down here so it nicely lines up here. And then we have to do 4 times negative 7y, which is negative 28y, or minus a positive 28y. You can look at it that way too. Equals, on the right side, we need to multiply 114 by 4, a negative 114 by 4, which is negative 456. So be careful, make sure you pay attention to the signs. Okay, so now we have two new equations. Well, they look new, but those two equations are the same as these two equations. The advantage here is now when we add, we can actually eliminate a variable. So now I can just add those two equations together and the y's will zero out. That's what I wanted to happen. One thing I want to address though is some confusion that often happens when I say you have what you do to one side, you have to do to the other. That's within a single equation. So between these two equations, I do not have to multiply equation 1 by the same thing I multiplied equation 2 by. So it's okay that I multiplied equation 1 by 7, but equation 2 by 4, because what has to be the same is that in that single equation, so if I'm looking just at equation 1, if I multiply by 7, I have to do it to both the left and the right side. Then I look at equation 2 totally separate from equation 1. It doesn't even have to exist, equation 1, for me to take equation 2 and multiply both sides by 4. Okay, so you do not have to multiply both of the equations by the same number. And if we always had to do that, then we would never be able to solve anything. It's just within the same equation, what you do to one side, do to the other. Okay, so we've got these two equations. Now we can do just like we did at the start of 8.3. Just add them together. Add left side to left side, right side to right side. Let's keep track of those equal signs and combine like terms. So 21x plus 20 is 41x. And then 28y minus 28y, that zeroes out, or plus a negative 28y will zero out, which is what we expected. That's the whole point of the elimination. And then we have 784 minus 456, or plus a negative 456, however you want to look at it, is 328. All right, so now we have a single equation with a single variable. So we can finish solving. So this is exactly like we've done many times before to finish it up. So notice that, again, we took those original two equations, we had to multiply them both by something to get matching coefficients, except one is positive, one is negative, so that when we add those two equations together, a variable eliminates and we were able to solve. So let's finish solving here by dividing each side by 41 to get rid of that 41. And we get x is equal to 8. Now we get to choose which equation that we use to solve for the second variable. And actually, you can use one of the original equations or you can use one of these. However, please don't, because I always tell you, don't use those equations that you adjust because you could have made a mistake. When I multiplied here, I could have messed it up and this equation is actually totally different than this one. So you have to be careful when you're doing that, but just to be safe, always, always, always go back to the original two equations. Another reason why you wouldn't want to use these two is because they're bigger. They have bigger numbers. So you're going to be multiplying by bigger numbers for no reason. Why wouldn't you use the simpler ones? So always refer back to those original equations. So I'm going to go ahead and choose equation number 1. It doesn't matter which equation you choose at this point. So it'll be 3, and then instead of x, we're going to put 8, because that's what we solved for x, plus 4y equals 112. Now we just need to solve that. So we have to do that multiplication first. 3 times 8 is 24. So 24 plus 4y equals 112. Simple two-step equation now. So we're going to subtract 24 from both sides to isolate that term with the variable. We had to isolate the 4y. So that zeroes out the 24 on the left side, leaving us with a positive 4y. Be careful, watch out for that sign. Equals 112 minus 24 is 88. And then our last step is to divide by 4. So y is equal to 88 divided by 4 is 22. Okay, now here is where it matters what equation you use to check your answer. Since I used equation number 1 to solve for the second variable, I already know that 822 for x and y works in equation number 1. So I want to make sure it also works in equation number 2. So I have to use equation number 2 to check. If you used equation number 2 to solve for the second variable, then you would check in equation number 1. All right, let's do our check here. So 5, and then instead of x, we're going to substitute 8, and then minus 7 times our y, which is 22. And we want to find out, is that really equal to negative 114? So order of operations, we have to do multiplication first. So we're going to do this multiplication, and this multiplication, then subtract. So 5 times 8 is 40. Minus, and then we can look at that as a positive 7 times 22, which is 154. So you can look at that two ways. You can do negative 7 times 22 and do negative 154, but you're adding a negative 154, which is the same as just minus 154. So is that really equal to negative 114? Let's type it in the calculator real quick just to make sure. And yes, it is. 40 minus 154 is negative 114. Great, so we confirmed our answer is correct. So we always write our answer as a coordinate point for our final answer. So x comes first, so 8, 22, and then let's go ahead and use solution sets. And so if you were to graph both of those equations, that is where they would intersect at 822. And that's it. Thanks for watching.